Water is one of the most important resources for life, yet many natural water resources such as lakes are often contaminated with suspended particles and impurities. Sustainable water treatment methods are become increasingly important as they help reduce environmental impact while maintaining water quality. In this project, we explore the use of papaya seeds as a natural coagulant for treating lake water. Papaya seeds contain natural compounds that can help bind and remove impurities from water through the coagulation process. Our study aims to evaluate the effectiveness of papaya seed coagulant in improving the clarity and quality of lake water, contributing to more sustainable water management practices.
The process starts with purchasing the papaya seed, extracting the papaya seed, drying it, grinding and sieving and mixing it with orbital shaker.
For the process methodology, the process starts by purchasing 3 pieces of fresh papaya, and the papaya was being sliced and cut. Next, the papaya seeds were extracted from papaya and the seeds were spreaded out on the aluminum tray. The next step was dried in the oven for 50 degrees Celsius for around 6 hours, and the dried seeds were grinded using a blender to fine powder. Later, the powder was sieved to get the fine texture. Next, by using the orbital shaker, the powdered papaya seeds were mixed with distilled water using 1:3 ratio 200 rpm for around 15 minutes to ensure efficient mixing.
The next step of our experiment is to study the percentage removal of the pollutant in our water sample by using the UVBs. Firstly, 2 sets of samples which are untreated lake water and treated lake water were collected. Both samples were ensured are filtered to remove the large debris. Based on the literature, the wavelength of 254 nm was selected, which is most commonly used to monitor the natural organic matter in wastewater. Then, the untreated sample was placed in a cuvette and absorbance value was recorded. Previous step was repeated by using the treated sample. Now, I'm going to show you how to calculate the percentage removal. The general formula is percentage removal equal to initial absorbance minus final absorbance over initial absorbance times with 100%. In my case, the initial absorbance was 0.4175 and after treatment, the absorbance dropped into 0.0963. Then, we substitute the value into the formula where we will get 76.95%. To be concluded, there is a high significant reduction in terms of absorbance which demonstrate that the treatment was highly effective.
Other parameter that will be tested for our water sample is turbidity. In our project, turbidity is measured using HACH 2100 Q turbidimeter. Turbidity quantifies the degree of cloudiness in water and is important in water quality metric. It is an optical characteristic of water and is a measurement of the amount of light scattered by material in the water. For turbidity analysis, the HACH 2100 Q turbidimeter was first switched on and prepared for measurement. Prior to measuring the turbidity of water sample, a blend measurement using deionized water was conducted to calibrate the instrument. After the blend reading was obtained, the instrument was ready for the sample analysis. Next, the water sample was transferred into a clean turbidity vial up to the marked line. The outside surface of the vial was then wiped using clean wipes to remove fingerprints that may interfere light scattering during measurement. The vial was placed into the turbidimeter sample chamber, ensuring that the orientation mark on the vial was aligned with the mark on instrument. The lid was closed and the measurement button was pressed to obtain the turbidity value. The turbidity reading displayed on the screen was recorded in nephelometric turbidity unit or NTU. The same procedure was repeated for the water sample after treatment using the papaya seed coagulant. The data measured for both before and after treatment was recorded as displayed. The efficacy of the papaya seed coagulant in reducing the water turbidity was determined using turbidity reduction equation, where T1 is initial turbidity and T2 is final turbidity. The turbidity of the water sample decreased from 138 NTU to 32.2 NTU after treatment with papaya seed coagulant, resulting in a turbidity reduction of approximately 76.67%. This significant decrease indicates that the papaya seed coagulant effectively removed suspended particles and colloidal impurities from the water, improving its clarity.
Next is the procedure to determine the chemical oxygen demand or COD of sample water before and after treatment by using papaya seed coagulant.
So I begin by measuring 2 ml of lake water treated with papaya seed coagulant and transferring it into a COD vial that already contains the potassium dichromate reagent. The vial is then closed tightly and gently shaken to ensure the sample mixes well with the reagent. Next, I measure 2 ml of untreated lake water and transfer it into another COD vial. Finally, I measure 2 ml of distilled water and add it into a separate COD vial as the blank sample, which will be used as a reference during the analysis. Next, the 3 COD vials containing the prepared sample are placed carefully into the COD reactor. After 2 hours of digestion in the COD reactor, the vials are carefully removed from the reactor. The vials are left to cool for about 1 hour to reach room temperature. The formula used is COD removal equals COD of raw sample minus COD of treated sample, divided by COD of raw sample multiplied by 100. First, the COD value of untreated lake water is 525 mg per liter, while the COD value of the treated sample is 421 mg per liter. After the substitution of value, the final result is 19.8%, indicating its ability to remove organic pollutants from the water.
The next step of our experiment is to test the pH of the water sample. This is to ensure the effectiveness of the treatment and to ensure the safety of the water for consumption. The pH of the lake water increased from 6.76 to 7.34 after the addition of papaya seed coagulant. This change indicates that the water shifted from slightly acidic conditions to a near neutral pH, which is generally favorable for water quality. The result suggests that the papaya seed coagulant helps improve the pH condition of the water while keeping it within the acceptable range for natural water.
In conclusion, this study demonstrated the potential of papaya dry seed powder as a natural coagulant for treating UTP lake water. The objectives of this project were successfully achieved. All in all, the results showed significant improvements in water quality after treatment. Papaya seeds also offer several advantages. They are environmentally friendly and biodegradable as they are derived from natural agricultural waste. They are also cost-effective and commonly available, especially in tropical regions where papaya is widely grown. In addition, making it suitable for small-scale or rural water treatment applications. Overall, exploring natural coagulants like papaya seeds provides a more sustainable and environmentally alternative for improving water quality and protecting water resources in the future.